In this video, I'll be discussing on printing counterbore holes without the need of excessive support. A counterbore hole is a type of hole that has two distinct sections. A smaller hole, which is this one, for the main fastener like a bolt, and a larger, shallow section to accommodate a nut. This design allows the nut to sit flush with or even below the surface of the material, which is useful for creating a smooth finish on part. Hi, I am Remy and welcome back to my channel. In 3D printing, creating clean counterbore holes can be tricky, especially for overhangs in the recessed area. This is where sacrificial layer or OrcaSlicer's bridge counterbore holes comes into play. This test print is with sacrificial layer added within the CAD software. This test print is without any sacrificial layer, but just by having extra parameter on overhang enabled. This test print do not have any sacrificial layer added from the CAD software, but bridge counterbore holes is set to partially bridge. On the bottom side, the circle is changed to an oval shape, but on the top side, it's fine. And also for this test print, no sacrificial layer added from the CAD software, but bridge counterbore holes is set to sacrificial layer. Now let's see the settings required to achieve this print quality. As of recording this video, I'm using OrcaSlicer 2.1.1. Let's see how to print this without a sacrificial layer. Once you import, set your layer height. So we'll slice this model and we'll lower down the layer height to the circle will start to print. So over here. Now let's do lower this slider to print to where the nozzle will start to print the circle. So if you see, the nozzle is starting to print the circle. Now this is printing mid-air, so definitely not get printed. So for this reason, we need to add a sacrificial layer. Now let's say you have a model like this to print. So maybe you can print in this orientation standing. You'll have to add some support over here and here, or you may get around this by adding some chamfer or fillet. You can also print in this direction, but you'll have to add lots of support over here. So the best orientation without adding any support or chamfers is to print in this orientation by adding a sacrificial layer. So this sacrificial layer will be only to this particular area, this circle what you see over here, this hole. Only for this particular hole we shall add a sacrificial area, because when the print head moves, it will move from this location, this point to this point in this direction, and it will create a thin layer of 0.2 mm. A sacrificial layer height must be matching to your printing layer height. I'll explain that later in the video. So now let's see how to add a sacrificial layer. So we need to create a sketch on this particular inner part. So what is selected over here? So you can click on this sketch button over here, or press the shift and S button on the keyboard. So this way this item this part will be selected, and now you can sketch on this. Now click the use button or press the U key on the keyboard, so this button, and select this circle. Okay, click on this. Now this circle is selected. Next click on OK, and now we shall extrude this circle inside towards the circle. So we'll click on the extrude button over here. Now click the sketch. Now if it is extruding outside, so we have to reverse the direction. So we'll set the distance to extrude, so 0.02 mm, and direction will reverse, and click on the add button and then OK. Now if you see, we have a sacrificial layer, so we can check the distance. So click over here and the inside part of this circle, and bottom down over here you will see it is 0.2 mm. Import your model in OrcaSlicer and slice it. So before that, my layer height is 0.2 mm and the first layer height is 0.28 mm. So let's slice this model, and now we'll navigate or bring the layer down to the sacrificial layer. So this is the sacrificial layer. Now here the nozzle is going in this diagonal, in this horizontal direction, and this will be a sacrificial layer for the top layer on top of this. So if you go to the next layer, so here this circle, if you see, this circle is able to be printed due to the underlining sacrificial layer. First of all, you have to make sure that you don't forget to add a sacrificial layer. And secondly, you have to make sure that your sacrificial layer is matching to your layer height, which is here, your layer height. Mine is at 0.2 mm. So my sacrificial layer must also be at the same height. So what will happen if it is not matching? So let's say my sacrificial layer is 0.2 mm. Okay. And if I am printing at a higher layer height, so let's say I have a higher diameter nozzle, so 0.6. So I will increase the layer height in order to print faster. So, or maybe there could be a different case or a different scenario. So let's see what happens if the layer height is increased. So let's say I'm printing at 3.6. So layer height is 0.36 mm. So we'll slice the model. Now if you see, we do not have that sacrificial layer. So it is printing like this. So there is no support. There is no support beneath this print area, which is this circle. So it is printing as if there is no sacrificial layer. I have loaded this 4 test model. They are almost identical in size and shape. Their dimensions is all same, except for this top circle, what you see over here. It is slightly larger compared to each one. Beneath this, you have this hexagonal shape, which is also same for all these models. So we'll select one of this shape, click on this measuring tool and see this size. The radius over here is 7.5 mm. For this one, it's 8 mm. Over here it is 8.5 mm. And here it is 9 mm. Now let's slice this and see how it will print. So we'll click this slice plate and we'll scroll down right over here. If you notice, you have this dark blue lines in circular pattern over here. These two lines, and over here these two, and over here these two. These are identified as overhang. We can validate over here. So just click on this drop down, and if you see overhang over here, just remove this tick mark. Just click on this, and if you see now that overhang has disappeared. These light blue lines, they are identified as bridge. That also we can validate. Click on this, and then this bridge option, if what you see here is remove the tick mark by clicking. So if you see here, now that is disappeared. Let's see how it is able to identify as overhang. Go under strength and wall loops. We have two walls, and if you see this particular shape, the outer wall, there is a layer beneath it, but the inner wall, which is in yellow, if you see these corners here, here, and here, uh, these are printing midair. So it is identifying it as overhang. Unlike over here, these two walls over here and over here, there is a layer beneath it. So because of this reason, uh, that it is printing midair at this particular location, it identifies as overhang. Let's see by increasing the wall loop. So we'll increase the wall loop over here. So from 2 to 3, we'll slice this. Okay. Now we have three walls. So one outer wall and two inner walls. Same over here as well. So we'll enable the overhang and see. So now right now it's visible. So we'll click again on this. Now if you see for these two shapes, it is identifying as overhang. So reason for that, we have this third inner wall, which is this third inner wall, which is printing midair in this corners. Now that we know that how it is identifying it as overhang, so let's see which parameter is responsible for that. So if you click on quality and then scroll down right at the bottom, if you see we have this extra parameters on overhang. I have had made a separate video on this. A link I will put in the description. So we'll enable overhang over here, this display option first. These are the overhangs, this dark blue color. Now let's disable this parameter and we'll slice the small plate again. Now if you see this overhang for this outer one is not there. So it's only identifying right at the circle where it is printing midair. Let's further increase the wall loop and see if we can achieve the same behavior for the bottom two shapes, which is 17 mm and 18 mm. Let's revert this parameter first, extra parameter on overhang. And go back to strength, scroll up, and wall loop we have set to 3. So we'll increase this to 4. Slice the plate. Now if you see, it has identified as overhang. Let's disable and see. This overhang will disable this view. Now that we have seen by increasing the wall loop, we can force the slicer to identify as overhang and get it printed by not having sacrificial layer or support for this kind of shapes. Most of the time we'll print with just two walls. In that case, adding a sacrificial layer is better. Let's see a different model with a sacrificial layer. This particular model, it has a sacrificial layer over here, 1, 2 and 3. So we'll see this particular hole. So we'll bring the layer down to that particular layer height over here, right over here. Now this is considered as bridge, which is here. If we increase the wall loop over here, let's see what happens. So it's set to 4. We'll slice. Now if you see here how it is printing, so it's not, it's going in a loop like this. So if you print this, this will fall, or this will droop down. So because there is no sacrificial layer, or it is not touching the parameter from one end to the another, it is just going in a loop like this. There is nothing for it to hold it. So we can see how it is printing over here. So if you see, it starts over here, and this particular layer, or this particular, when it is laying down this particular layer line, there is nothing underneath. So this will drop down. This happens because we have this under quality. We have this parameter enable, which is enabled by default. So this will override if we have set or if you have added a manual sacrificial layer. So let's remove this, slice this plate. And now if you see, you have your manual sacrificial layer back. So if you are adding manual sacrificial layer, make sure this is unchecked, as this will identify as overhang if you increase the wall loop. So before you do any prints, make sure you slice and see if there are any such behavior where it can ruin your prints. This must be enabled actually by default, because this helps if you have actual overhang. not in this case. So let me slice this again. So this is a case where we are increasing this uh, the wall count, and that is why you are getting this behavior. In normal scenario, this should be enabled because it will help you in getting print quality better for overhang. Now that we have seen how to print inverted counterbore holes with the help of adding a manual sacrificial layer within the CAD designing tool, or by increasing the number of wall loops and with the help of extra parameter on overlap option enabled. Next, we'll see another method to achieve the same without adding additional sacrificial layer, or by increasing the wall loops within OrcaSlicer. Now let's see with bridge counterbore holes parameter. So under quality, scroll down right at the bottom, and over here bridge counterbore holes, you have two options: partially bridge and sacrificial layer. So we'll check first the sacrificial layer. We'll slice the model. Now if you see here, over here, these two models, we have the sacrificial layer being generated within the OrcaSlicer. But for these two models, it's not. So here it's identifying as overhang because the let me undo or disable this overhang. So it's identifying this model or this shape as an overhang because of the inner wall, this yellow color inner wall. Over here it is as an overhang. So for this it detects as an overhang. Now let's see for this. We'll disable this bridge. Now if you see here this particular corners, there isn't much gap. It's right at the edge over here, the inner wall, that is yellow line. So there is no much overlap for OrcaSlicer to create the bridge. So it's unable to detect uh, that as a sacrificial layer. So it's not creating because of lack of gap over here. So this should be little wider, that is towards this side. So the circle should be little bigger. Only then it will be able to identify. Over here, if you see this particular shape and this one, there is enough gap uh, between this angle and the line, so it is identifying it as a bridge, and it is creating this bridge dynamically. So for both this, now in order for all this to create it as a bridge by this parameter bridge counterbore holes, if you change this to partially bridge, then you enable this bridge, then you will see it is able to create the bridges. So if you select sacrificial layer over here, then it is not able to identify for these two particular shapes to create a sacrificial layer. But if you select partial bridge, then it is creating as a bridge layer. So that was for shapes not having sacrificial layers, not being added within the CAD software. Now let's see what will happen if we do the same for models having sacrificial layer. Now I have this 4 test print loaded into OrcaSlicer. They are the same as before. Only thing I have added manual sacrificial layer within the CAD software. So you can see over here, you have this hole here, here, here and here. And if you look from underneath, there is a 0.2 mm sacrificial layer. From setting point of view, if you see, I have disabled this bridge counterbore holes. It says it is none. Extra parameter on overhang, this is enabled. from strength, under strength, wall loop is set to 2. So we'll slice this model. Over here, this is being bridged because of the manually added sacrificial layer, and over here it is converting to that as a overhang. Now let's increase the wall loop and see what's the change. So earlier we had this particular shape as this has identified as overhang. Now the second 16 mm one is also identified as overhang after increasing the wall loop count. We'll further increase and see. Further increasing now 15, 16 and 17 mm, they are now converted to as overhang. Now let's enable under quality and bridging. Let's enable bridge counterbore holes. We'll set this to sacrificial layer, slice. Now under setting, if you see, our wall loop is set to 4, but this one has changed back to the sacrificial layer. While having sacrificial layer added from the CAD software, and if you want to maintain a sacrificial layer no matter what, then we need to make sure that we disable under quality. We need to disable extra parameters on overhang. So we need to remove, uncheck this. You can slice the model and we'll have the sacrificial layer back. And now this was before this it was identified as overhang because this parameter was enabled. So after disabling it, it is gone back to sacrificial layer. Another option is to change bridge counterbore holes from sacrificial to partial, and let's re-enable this. Now we'll slice the model. This way also, without disabling this parameter, extra parameters on overhang, you can get back the manually added sacrificial layer. In my opinion, there is no need to add any sacrificial layer within the CAD software. There could be some edge cases where it might need. Let's see this scenario. We have this two test model. Both are identical. Only difference is this one does not have a sacrificial layer and this one do have a sacrificial layer added in the CAD software. Having bridge counterbore hole set to sacrificial layer and enable parameters on overhang is enabled. Let's slice this and see. Now this has a sacrificial layer, so it is converting it to a bridge. This does not. So you have extra parameter on overhang taking action over here. So this is converting to overhang. In this case, let's say if you disable extra parameter on overhang, this particular model will not get printed. Let's see. Disable and slice. Now if you see, this is taking it as a bridge, and the circle it is taking as overhang. So it will start to print the overhang first, or there is no underlining layer, so it will not get printed on top of any layer, so it will drop down. So in such scenario, it is better to enable extra parameter on overhang and change bridge counterbore holes from sacrificial layer to partial bridge. Let's slice. Partial bridging has taken place. Thank you for watching this video. I would love to hear your thoughts, so feel free and drop a comment below. Don't forget to like and share if you found this video helpful. God bless and stay safe.